Hi guys, in this video we will be covering slant asymptotes. You know what horizontal asymptote is? It is the sorry, horizontal asymptote is an invisible horizontal line which the function is approaching as x is approaching to positive or negative infinity. You know the vertical asymptote. It is the invisible vertical line that function is approaching as x is approaching to a fixed number. Now we are going to be talking about slant asymptote. Slant asymptote is an inclined invisible line. It's not horizontal, not vertical. It's inclined either this way or that way that function is approaching. So how are you going to find slant asymptote? First of all, we need to know that if the degree of the degree of the numerator is 1 more than degree of the denominator, then we have a slant asymptote. Okay, this is important. Degree of the top should be 1 more than degree of the bottom, then we can talk about slant asymptote. And in order to find slant asymptote, we have to do the long division. So when we do the long division, we are going to write the numerator as a dividend, denominator as a divisor, and the quotient will be written at the top. The result will be written at the top. We will have a remainder, and when we write the result as a new form of function, we are going to write this as the quotient, which is slant asymptote, plus remainder divided by the denominator, by the um, divisor. Okay, this is how we write the new function after the long division. So let's solve questions. First question, a mystery question. Which one is the slant asymptote of this function? So first way of solving this question is using long division. So write the numerator as a dividend, 2x squared minus 4x, and denominator as a divisor, and divide. Remember how to divide. Just take the leading term first, divided by the leading term of the divisor. So here I have 2x. So write 2x as a quotient. Multiply 2x by the divisor one by one. 2x by x, 2x squared, plus 2x by 1, 2x. Now subtract 2x squared minus 2x squared is 0, minus 4x minus 2x is minus 6x. Can I do the same one more time? Actually, I can. The result is negative 6x. I can divide the result by the leading term of the divisor, which is x. When I do, I'll get negative 6. So write negative 6 right next to the 2x as a quotient. So multiply negative 6 by the divisor, negative 6 by x, negative 6x, negative 6 by y, 1, negative 6, and subtract. 6x's will cancel, 6 will remain. So the quotient will give me the slant asymptote, which is option D, 2x minus 6. Okay, if you want to write the new function, you can write this as f of x equals the slant asymptote, which is 2x minus 6, plus the remainder 6 over the divisor denominator. So this is also a way of rewriting the function, but question is not about this. We will be using this in one of the exercise questions. This is how we find slant asymptote, by making long division. This is the first way. Can we solve it in another way? Yes, I think so, we can. What we need to do to solve it without doing long division is trying options. When you try options, pick one of the options and multiply the option by the denominator. Our denominator is x plus 1. Multiply it by every option one by one. Let me start with the correct one. So when I do this, let's distribute 2x squared minus 6x plus 2x minus 6, which is 2x squared minus 4x minus 6. So when I do that, the first two terms of the result should appear at the top. Okay, I multiply each option one by the denominator, and the correct answer in the correct answer, first two terms of the answer should appear at the numerator. Okay, this is a way. So this is how its graph look like. This is our function, and we have a slant asymptote, an inclined line that function is approaching. Okay, let's take a look at the ministry exam question. Slant asymptote is given with two unknown. Function is given. Find the values of a and b. So to find the slant asymptote, we have to do the long division, because in the options we don't have the slant asymptote, so we cannot try options. We can actually one by one, but I think long division is better here. Top is x squared minus 3x plus 2. Bottom is 3 minus x. Divide the leading term of the numerator by the leading term of the denominator. It's going to be negative x. Multiply negative x by the divisor. Negative x by 3. Negative 3x. Negative x by negative x. Positive x squared. Subtract. X squared negative x squared is 0. Negative 3x positive 3x 0. 2 will come down. So our slant asymptote is y is equal to negative x. In this case, the coefficient of x is negative 1. So a is negative 1. And there is no constant. So b is 0 then. A negative 1, b 0, option C. Okay, it's pretty simple question. Long division doesn't take much of your time because there's just one step. One last ministry exam question, and then I finish the lesson. Which of the following functions has a vertical asymptote at x equals 3 and slant asymptote at y equals negative 2x? First of all, in order to have slant asymptote, degree of the top should be 1 more than degree of the bottom. In option A, degrees are same, so there is no slant asymptote. Option B, yes. Option D, yes. C, yes. What about vertical asymptotes? It's x equals 3. In option C, when you insert 3 back, you're gonna get something over 0. Yes, it gives you vertical asymptote. Option B, substitute 3, you're gonna get a number over 0. Option D also a non-zero number over 0. So all three options have the same vertical asymptote at x equals 3. So the slant asymptote will determine our answer. So you divide top by bottom for each option one by one. But when you try option D, negative x squared over x will give you negative x, not negative 2x. So you can also eliminate option D, right? When you do long division, you divide the leading terms. Then option D doesn't give you negative 2x. So try B and C one by one. Option B, for example, top is negative 2x squared plus 6x plus 1. Bottom is x minus 3. Divide negative 2x squared by x, which will be negative 2x. Multiply negative 2x by the bottom, negative 2x by x, negative 2x squared, positive 6x. When you subtract, everything will go except 1. So our slant asymptote in option B is y equals negative 2x, which is true.